This is triangle problem solving. Let's talk about using the law of sines and cosines and when it's appropriate to use the law of cosines versus the law of sines. Now for this lesson you're going to need the following items: a red, blue, and green color pencil, a ruler, a number 2 pencil, and a scientific calculator. If you need time to collect any of these items, go ahead and pause the video now. Our goal in this lesson is to learn how to solve problems involving triangles. As problem solvers, we need to learn when it is appropriate to use the law of sines or when it is more correct to use the law of cosines. Okay, let's get started. Here we have the following triangle ABC. Looking at this picture, here's the question we should ask ourselves first. What do we know about this triangle? Go ahead and pause the video and then write a sentence about what you know by looking at this particular figure. Here's what we know. We only know the sides of the triangle. And when this happens, when you only know the sides of a triangle and none of the angles, that is an indicator into which law to use. So, which law is the correct law to use? What do you think? Pause the video and think about it. Here we go. The correct law to use is the law of cosines. And the reason? Because we only know the sides and none of the angles. Okay, let's color the side opposite angle A in red. Let's color the side opposite angle B in blue. And let's color the side opposite angle C in green. Here we go. Opposite angle A in red. Opposite angle B in blue. Opposite angle C in green. Now let's solve for angle A. So what I'm going to do is I'm going to set up the law of cosines formula. I have purposefully colored the boxes red, blue, and green for a specific reason. Because I chose to solve for angle A, this means I need to begin the equation with the side opposite A, which is 7 centimeters. So I begin with 7, and then I use the other two sides in the right-hand side of the equation. So what happens is the equation becomes 7 squared equals 9.3 squared plus 8 squared minus 2 times 9.3 times 8 times the cosine of angle A. Notice angle A is the only variable in this equation, so that's the variable we have to solve for. Okay, let's focus now on how we go about solving for angle A. First thing I do is I'm going to subtract 9.3 squared and 8 squared to the other side of the equation, and then I'm going to divide by negative 2 times 9.3 times 8. This will give me the cosine A. Here's a quick illustration of that process. Take 7 squared, subtract 9.3 squared, subtract 8 squared, divide by negative 2 times 9.3 times 8. And this is equal to the cosine of A. Now let me show you how you can take your TI-84 or scientific calculator and calculate this value. So I type in parentheses 7 squared minus 9.3 squared minus 8 squared, and then I close the parenthesis, divided by another parenthesis, negative 2 times 9.3 times 8, and then I hit enter. This gives me the cosine of A. So, to figure out angle A, I have to take the cosine of this answer. I get 46.99, so we're going to round to the whole number, so angle A is 47 degrees. Remember, every time you calculate something in your scientific calculator, it gets stored in a temporary variable called ANS, which is short for answer. So in other words, after I calculated the fraction, I got 0.6820564516. That was the cosine of A. To figure out the angle, I had to do the cosine inverse of that value. So okay, I got the measure of angle A is 47 degrees. I now label angle A. Now, I want to find angle B. Well, in order to do that, I can change the equation from being cosine A to cosine B and set up the sides accordingly like this. 9.3, I forgot a square there, so I apologize for that. That should be 9.3 squared equals 7 squared plus 8 squared minus 2 times 7 times 8 times cosine of B. But I want you to also know how to use the law of sines. And the really cool thing is that once you have used the law of cosines once, you only need to use it one time. So here is the law of sines. The sine of angle A divided by A is equal to the sine of angle B divided by its opposite side is equal to the sine of angle C divided by its opposite side. So we set up the equation accordingly and do a cross product. 9.3 times the sine of 47 degrees divided by 7 is the sine of B. So now let me show you how to calculate that. I take 9.3 times the sine of 47, make sure your calculator's in degree mode, divide by 7, I get the following value, which is the sine of A. Sine of B, I have to take the sine inverse of that number, and this gives me angle B. So angle B to the whole number is 76 degrees. Now we can find the remaining angle C, which is even easier, because the angles in a triangle have to add up to 180 degrees. So therefore, 180 minus 76 minus 47 is 57 degrees. And now I know that angle C is 57 degrees. Let's look at this triangle, and let's ask ourselves, what do we know about this triangle? Well, here's what we know about the triangle. We know two sides and the intended angle. The intended angle is the angle that is between the sides that we know. So the question is, which law is the correct law to use? And again, the answer here is the law of cosines. So this gives us two cases now where we know when the law of cosines is correct. And we'll specifically talk about those two cases right at the end of this video. So I want to solve for the little c, which is the opposite side to angle C. So I set up the equation in the following way. Little c squared equals 9.3 squared plus 7 squared minus 2 times 7 times 9.3 times the cosine of 57 degrees. C squared is 64.57. So C is equal to 8.03. To the nearest tenth, that would be 8. But that confirms what we already knew from beginning this lesson. So there are two cases when you know that the law of cosines is appropriate to use. Number one, when you only know the sides of the triangle and none of the angles. Number two, when you know only two sides and the intended angle between them. And that is how you work with the law of sines and with the law of cosines. God bless you, wherever you are today.